Blinking LEDs with timer interrupts on the dsPIC33FJ64GS606. Welcome to MeviHub.com, your go-to destination for all things electronics and embedded systems. Today, we have an exciting topic to dive into: blinking LEDs with timer interrupts using the powerful dsPIC33FJ64GS606 microcontroller. In this video, we will explore the specifications of the dsPIC33FJ64GS606, examine the timer setting registers, and learn how to calculate the timer frequency for precise LED blinking effects. So, let's get started. Required components: microcontroller, dsPIC33FJ64GS606. Programmer, PIC33FJ programmer. LED. Connection wires. Welcome to MeviHub.com, your go-to destination for all things electronics and embedded systems. Today, we have an exciting topic to dive into: blinking LEDs with timer interrupts using the powerful dsPIC33FJ64GS606 microcontroller. So, let's get started. Specifications of microcontroller. Core type, dsPIC33F. CPU speed, 40 MIPS, 10 MHz flash memory, 64 kilobits. SRAM, 8 kilobits. Operating voltage, 2.5V, 3.6V. Number of pins, 64. Timers, 5 timers. Analog to digital converter, ADC, 10-bit, up to 16 channels. Digital to analog converter, DAC, 2x 10-bit DACs. Pulse width modulation, PWM, up to 10 channels. Serial communication interfaces, UART, SPI, I2C. Inter-integrated circuit, I2C, 2 channels. Universal asynchronous receiver/transmitter, UART, 2 channels. Serial peripheral interface, SPI, 2 channels. Timer setting registers. To begin, let's take a look at the circuit setup. We'll connect an LED to one of the microcontroller pins and configure the necessary settings to enable blinking using timer interrupts. Timer register, TMR. The timer register, TMR, holds the current value of the timer counter. By accessing and manipulating this register, we can monitor and update the timer's value during operation. Period register, PR. The period register, PR, determines the timer period or the value at which the timer counter should reset. By setting the appropriate value in the PR register, we can achieve the desired time delay. Prescaler select bits. The prescaler select bits, TCKPS, allow us to divide the input clock frequency and adjust the timer's resolution. By selecting a prescaler value, we can divide the clock frequency to achieve the desired timing. Clock source select bit, TCS. The clock source select bit, TCS, determines the clock source for the timer module. We can choose between an internal clock source, such as the system clock, or an external clock input. By selecting the appropriate clock source, we ensure accurate timing. Interrupt enable /flag bits, TIE/TIF. The interrupt enable, TIE, and interrupt flag, TIF, bits allow us to enable or disable the timer interrupt and indicate whether a timer interrupt has occurred. Interrupts are essential for precise timing and executing actions at specific intervals. Timer frequency calculation formula. The timer frequency, timer, can be calculated using the formula, timer equals C. Prescaler, PR plus 1. Where C represents the system clock frequency, prescaler is the prescaler division factor, and PR is the value in the period register. Example for better understanding. Let's consider an example. Suppose we have a system clock frequency, C, of 40 MHz and want to achieve a timer frequency of 100 Hz, 10 milliseconds period. To calculate the value for PR, we rearrange the formula as PR equals C. Prescaler of timer, 1. Calculation steps and result. Plugging in the values, we get PR equals 40 million. 8 times 100, 1. Simplifying further, PR equals 49,999. Therefore, setting the PR register to 49,999 will achieve a timer frequency of 100 Hz, giving us the desired 10 millisecond period. Thank you for watching this video on blinking LEDs with timer interrupts on the dsPIC33FJ64GS606 microcontroller. We explored the specifications of the dsPIC33FJ64GS606, examined the timer setting registers, and learned how to calculate the timer frequency for precise LED blinking effects. If you enjoyed this video, don't forget to subscribe to our channel for more educational content on microcontrollers, embedded systems, and much more. Happy coding, and we'll see you in the next video.